My name is Michael Paul, and this is my individual project, number 1. So what I've built here is a analog speedometer for a longboard, and essentially how it works is it has a photo IR LED and a photo transistor put on the axle of the longboard, and then they have basically an interrupt that comes through. It's a black piece of tape, which breaks that connection, which causes a voltage change on the output of the phototransistor, and that generates a pulse width modulation signal, or a square wave basically for me. And so that is being fed into a frequency modulator 555 circuit, which is this one right here. So it inputs that signal, which is basically, it has a fixed voltage on pin number 5, and then as we modulate that input to the trigger, it outputs a square wave. And so that is controlled by this LED. So as you can see, when the beam is broken, it goes on. And then also connected to the output of the frequency or pulse width modulation 555 timer circuit is a monostable circuit, which I've used as a frequency divider. So it takes the output frequency that the first LED is experiencing and will divide it. And so right now, that since the beam is broken, this LED will constantly be on, but if we start to spin the wheel, they blink at different rates. And so basically it sends a pulse width modulation signal to the LED. And so at slow speeds, you can see that the LED on the right is a little bit easier to follow, but as we increase speed, it basically becomes the same, but this LED over here blinks a little bit slower, so it's easier to tell how fast you're going using the second LED. And this idea could be expanded and more fine-tuned to get a specific range, and you could do every mile per hour or up to 10 miles an hour. Or you could make them make the frequency go basically to where the LED would come on at every mile per hour. So I just did a proto of that, and mine's also hooked to a voltage source, which could easily be replaced by a battery if you wanted to cruise around. But I just left it as this because I did not want to go buy batteries. So that's my circuit.